What's up, guys? Happy Easter, everyone. This is the Wine Science Commentary. My name is Lawrence, and today we look at a paper how different yield levels impact the style and quality of your wine. If you're into that kind of stuff, then you might want to consider subscribing to the channel. That's it from my side. Let's jump into it. This week's paper is called Sensory Attributes of Cabernet Sauvignon Wines made from vines with different crop yields. Head research here was Don M. Chapman and Mark M. Matthews, and that paper was published in the American Journal of Enology and Viticulture back in 2004. And let's look at the researchers. So this is Don Chapman. She holds a degree in mathematics and chemistry and received a PhD in food science with a sensory emphasis from UC Davis. And if you scroll down here, you see her CV, and she's quite focused on this sensory, in the sensory field. So that's her expertise. And then Mark M. Matthews, professor at UC Davis, of course, and plant physiologist, very well-known guy. Let's go to the introduction. Traditionally, low-yielding vineyards have been associated with higher quality wines. This belief has been held since the Middle Ages and is still held, in my opinion. I also think the lower the yield, the better the quality, to a certain extent, of course. Surprisingly, few studies have been conducted to determine how wine aromas and flavors are affected by crop yield. Yes, there are some old studies, old but gold, of course, but no recent studies in this field. And 7 studies found no effect or no consistent effect of yield on wine quality scores. So then the objective of this study was to investigate the effects of yield manipulation through wine pruning and cluster thinning on the sensory attributes of Cabernet Sauvignon wines. Okay, so far so good. Materials and methods. So here they used grapes. They used Cabernet Sauvignon grapes planted in the Napa Valley. And let's look at the experimental design. I created a small PowerPoint for you. So the first experiment, I call it the pruning experiment. This is quite easy to understand. So they pruned vines to a different level of buds at the start of the season to 12, 18, 24, 30, 36 and 48 buds per vine. And these wines were then investigated over 2 seasons, 2000 and 2001, and every treatment here was replicated 6 times. Alright, and then we have a second experiment, the so-called cluster thinning experiment. This was kind of combined with a pruning experiment as well. So we have 2 categories of wines. The one category was pruned to 24 buds per vine in winter, and the other one to 48 buds per vine. And then these 2 categories got different cluster loads. So some clusters were removed aberration, and then this category here had 12, 24, 36 and 48 clusters per vine. And the other category had 48, 64, 72 and 96 clusters per vine. And then you see you have one treatment where both wines, despite being pruned to different buds at winter, have the same clusters at harvest. And this experiment here was just conducted over 1 season in 2001, and again you have 6 replicates per treatment. And furthermore, the wines were then fermented in triplicates. The fruit was crushed, destemmed and separated into 55-liter plastic fermentation vessels, and these wines were then bottled, and a year later they were evaluated by a descriptive sensory panel. So they describe here how the sensory panel was trained actually. So for both panels, panelists attended 3 1-hour sessions per week for 4 weeks. So quite intensive training, that's of course necessary. And then let's look at some results here. So this figure 1 shows us buds per vine in relation to the total yield, and we see as buds per vine increase, also a yield increases until a certain extent here, where you see only a small increase from 36 buds per vine to 48 buds per vine. And then you see this dark circle here represents the yield in 2000, and this 2000 yield is quite higher than compared to 2001, because here they overcropped the vines drastically, which led to a decrease in fruitfulness, and then you have a lower crop the year after. And then figure 2 shows clusters per vine in relation to yield, and you see as the amount of clusters increase, also our yield increases until we reach this compensation point here, which starts at, in this experiment, 72 clusters per vine, and the jump from 72 clusters per vine to 96 clusters per vine, meaning the yield doesn't increase too much from this point to that point, because your clusters just get smaller and smaller and smaller. A vine cannot produce an infinitive amount of yield, so it just end up with smaller clusters. So far so good, and now we're gonna look at some sensory tables here. So these are the results of the pruning experiments, and what they did was they tasted all the wines from different bud loads, and when you see a highlighted term here, that means that the vines from different bud loads did differ in this descriptor. And then you see, when you make wines from different bud loads, in this experiment they differed in 10 out of 15 descriptors in the year 2000, and in the year 2001 they differed in 9 out of 15 descriptors for the pruning treatment. And then if you make wines from different cluster amounts, as they did in the second experiment, you see here that you only have 3 different descriptors. So the wines only differed in 3 different attributes here, whereas in the pruning experiment you have like 70% of all descriptors differ dramatically. So this is already quite interesting. And then you see here on the x-axis we have buds per vine, and on the y-axis we have average intensity rating of, for instance, fruit by mouth. And you see, as buds per vine increase, also your average intensity of fruit by mouth increases, your cherry flavor increases, and your fresh fruit flavor increases. And as buds per vine increase, your bell pepper aroma decreases, your veggie aroma decreases, and also your veggie by mouth intensity decreases. This is absolutely amazing, because you would think it's quite the opposite. No, the more crop, the greener your wines get, but no, it's quite the opposite in this experiment. And what happens here with astringency is that as you increase your yield, you lower the astringency of the wines. You see here you have this decrease of this curve. And then we have a nice PCA here. On the right side, from 0 to 1, we have these attributes like veggie by mouth, bitterness, black pepper, bell pepper. And from 0 to -1, we have this fruity characteristics. And you see all the wines which were made from a higher bud level at winter time are grouped more on the left side, meaning they are more fruity, whereas the lower bud wines are located or grouped on the right side, meaning they are more green, more bitter, more black pepper, more bell pepper. Quite interesting so far. And this is the PCA which shows results from the cluster thinning treatment. And then you see these black points here, or black dots here, are the wines which resulted from the 48 notes per vine, and they're quite clustered together, whereas the 24 notes per wines are also quite clustered together. And then I showed you in the beginning there were 2 treatments which had the same amount of clusters but resulted from different notes per vine at pruning, and they're quite different in taste, because you have this massive gap here, meaning they have the same amount of clusters but they were pruned differently, resulting in different taste. Wow, very astonishing. And that was the small presentation, and now let's look at the discussion and the conclusion down here. Wines made from vines with different yields had significantly different sensory attributes. In general, lower yields produced wines with high intensities of astringency and veggie aromas and flavors. However, the impact of yield on wine sensory attributes was greatly dependent on the method by which yield was altered. Yeah, as we saw in the beginning, when yield was altered by pruning, we have quite different wines, whereas this cluster thinning treatment led to wines which were quite similar actually. And then somewhat surprising was the consistent observation that the intensity of fruit aromas and flavors was positively correlated with yield. Yeah, so more yield, more fruitiness we had in this experiment. And then here to write veggie aromas and flavors in Cabernet Sauvignon wine are generally not considered desirable. and the data clearly shows a reduction in vegetative intensity with increasing bud number. Yeah, so higher bud number resulted in less green aromatics in this paper here compared to a lower bud number, which showed a decrease of this green flavor attributes. And in the conclusion they say, we interpret the results to indicate that the pre-season pruning treatments had a larger effect on the sensory properties of the resulting wines than the mid-season thinning treatments. As bud number increased by winter pruning, fruit tree attributes increased in intensity and veggie attributes decreased in intensity. Okay, and then some literature here. That was the paper. So what did we learn from this paper? What is our take-home message? We see that if you produce wines from different crop levels or different yields, they differ quite a bit, but in this experiment it was more dependent on which method was used to alter the yield. So this pruning had a much bigger effect on the overall wine style than cluster thinning itself. And I also have to say that cluster thinning is way overstressed in our industry. If you do it too late, then you don't have a big effect at all, and if you do it too early, then your wine just makes up for it and the clusters get bigger and you also lose the effect again. So yeah, you have to find the right balance for each vineyard, I guess. And I'm also a big fan of early leaf removal. I'm gonna do a paper on that pretty soon.
That's it from my side, guys. I hope you enjoyed it. Next week we will see how organic, biodynamic and conventional winemaking, wine growing differs from each other. I hope you also stay tuned for that.